Good morning, everyone, and welcome to today's Autodesk Virtual Academy brought to you by KETIV Technologies. I'm Nigel Mbaye, Customer Success Manager here at KETIV, and I definitely welcome you all to our great session today. Usually I'm joined by somebody else, but today I'm actually doing the demonstration myself. Sit tight for about 30 to 45 minutes here while we go over the demonstration as well as some Q&A. If you do have any questions, go ahead and type those into the GoToWebinar chat panel at any time. I'll make sure to go ahead and answer those at the end of the webcast or during, if it really makes sense, or maybe we have a pausing period while we're loading a couple of things. So with that, let's go ahead and get started. Today we're talking about the Inventor Nesting Utility. And as you can see here on the screen, there is a bird's nest. That is not what we're nesting today. Just a little something silly for today. And so we're going to talk about what nesting utility is, who has it, who has access to it, how you get access to it if you don't already have access to it, what it does, what are some good use cases for it, and then how to to perform the picks and clicks to get through the actual nesting functionality within Inventor itself. So let's go ahead and get started. All right. So first off, let's go ahead and answer that question. What is nesting? Maybe some people on the call aren't familiar with it. I know I wasn't super familiar with it until, I started learning a little bit more about some of the manufacturing software we have here. And so first off, what is nesting? First and foremost, nesting is the concept of laying out cutting patterns to minimize raw material waste. What that means is, you can kind of optimize yield of your raw materials by orienting them a certain way, putting them in different orientations, as well as putting them super close to each other, so that when you do actually cut this stuff out of your raw material, your remnants are minimized, right? You have less space between components, and maybe you preserve a piece of that original stock to use later. Second of all, it's usually from flat raw materials such as sheet metal, and that's the use case we're going to go over today. Is how to optimize the yield of sheet metal by using some automatic nesting software, right? It uses algorithms to be able to orient and place these items in a certain way so you get the most out of your material. And then lastly, it's something about birds. When I was looking up nesting, I was getting a bunch of pictures of bird nests. So there's a good picture for you. All right, let's move on a little bit. And right here is what's included in the product design and manufacturing collection slide here. And the reason this is important for this particular presentation is because the nesting utility is a crucial part of the Inventor streamlined workflow, the in-canvas workflow, some say, in which all of those 5 components at the top there, Inventor, Nastran, HSM, nesting utility, and factory, all happen natively inside of your Inventor application. Yes, they are separate applications within each other, but they're actually just modules that you use inside of Inventor. And that's kind of the whole concept of the product design and manufacturing collection itself, is you get to use this cool in-canvas workflow where you get to go from simulation to nesting to factory layouts, and then ultimately post out some of this information to your machines, right, in the machine shop to actually generate your parts and assemblies. In addition to that, the nesting utility is the newest addition to the PDMC, right? So with the addition of Inventor 2019, we got the nesting utility as part of the product design and manufacturing collection. So those of you who have PDMC, you do have the nesting utility in 2019. In addition to that, right, nesting utility only works with Inventor 2019. So hopefully that answers some of those questions before they maybe even come in. So with that, go ahead and take a look at that for a second. If you have any questions about any of this information about the PDMC, let me know. I will be able to answer that for you. So what are we going to be looking at today? So we have this snowplow assembly here. This is just a picture of it, right? I'm not an inventor. We have this snowplow assembly here. It's comprised of, let's say, 150 or so parts, a lot of which are sheet metal components, right? They're built in sheet metal, they're bent, and then they're put in this assembly. And what we want to ultimately do is we want to be able to manufacture all of these components. I've seen some cases where customers, take individual DXFs of the flat patterns of each individual component and send those individually to maybe a third-party nesting software. Or maybe they even post out all of those individual parts themselves. Not super ideal when you have assemblies of size of, even like 10 or greater. let alone something like 50, 60, into the hundreds. And that's where the stuff on the right side comes in, right? So those are generated nests, right? So you can see that some of those components are all, you get all those flat patterns together, and they're all optimized in a certain way so that you get the greatest use of your material. So that's what we're going to be going over today. I'm going to show you how to turn what's on the left into what's on the right, and then ultimately be able to send that out to your CNC software to go ahead and post those out to your machine guys. Cool. So let's go ahead and just jump straight into Inventor and exit out of this. Close that out and jump into Inventor. All right, so I'm in Inventor now. As you can see, I'm using the same assembly as we had before. Let me move over some stuff so I have more screen real estate here. Awesome. All right, so this is that assembly I was just talking about. It's 78 components. There's 47 unique ones loaded right now. So we're going to go ahead and take a look at this. First and foremost, right, as you can see, a lot of these components are sheet metal components. And what that means is they're built in the sheet metal environment. In Inventor, right, there's just a simple part that I built here in sheet metal. And then you have the ability to generate flat patterns off of this information, right? And what a flat pattern is taking this component and generating the flat, pre-bent peaks, right? This is going to be some 1/4 inch sheet metal, for example. And then someone's going to use these bend lines as reference to go ahead and bend this out into the final shape, this folded part here. And so instead of, taking all those flat patterns, exporting DXF, sending that to another machine, that could be very, very time consuming. We want to be able to do that right in Canvas here inside of Inventor. That's really, really what we're going to go after today. So the first thing you need to do is obviously install the nesting utility. I've already done that. I'm going to assume that you guys have already created your assemblies or your parts. And then you can simply go to the actual assembly name here in the model tree, right? So make sure you're hovering over this or click it. You're going to go ahead and right click this. I'm going to go slowly, right? I don't want people to miss out on how to get to this. It took me a while to find this myself. Is right click the assembly, and then in the same place where you create those drawing views and create IPN files, you have a new option called Create Nest. And what that's going to do is going to open the nesting environment and go ahead and generate that for you. As you can see, if you're just opening a file or you start a new file, I'll just do that. You have the ability to open a brand new nest from here, and this is just going to be a nest that's unpopulated. So just keep note of that. Is you can either open a brand new one from here, or much like you can with drawings, generate one straight from the assembly file that you're already in. So I'm going to go ahead and create this nest. It's going to give me this dialog box here that shows me, hey, what do you want to do? I want to create a new template, a new nest from a particular template, right? Default, inches, millimeters. I want to add to an open document. It's going to look at your open documents. And do you have any files that are .inest open? And that's the nesting file type. It's inest. And so I have a couple open. I could go ahead and add it to that one, or I could go ahead and add it to that one. I'm not going to. And I can add to an existing document. Say I have a file that's a nest that is saved in memory somewhere on my computer, or not saved in memory, saved on my hard drive somewhere on my machine. I can go ahead and add to that. It's going to let me browse for a particular file, right? And I can go ahead and open that and add it to that existing document. For this particular example, I'm just going to start from scratch. I'm going to assume you guys haven't opened a nest yourselves. And I'm going to go ahead and click standard inches. I'm going to go ahead and hit OK out of this. And it's going to chug along here for a couple of seconds while what it's doing essentially in the background there is it's looking at that assembly for all of the possible components that have flat patterns. Anything built in sheet metal that has a flat pattern, it's going to grab that information. And so what it did is it found all of those components, and it found all of the materials for those components. And this is really key too, right? Since it's built into Inventor, it understands what material the part was actually designed in, right? In this case, all of these things were designed in mild steel with varying thicknesses. And that's also the key here too. With nesting it's one thing to put all of the components in the same orientation or into an orientation and location that yields you the biggest yield off of your material. But secondary, you want to be able to combine them in a way that all of the like thicknesses are together, right? It doesn't make any sense to nest a 1 inch thick part with a 1/4 inch thick part. that's probably not going to happen. Or actually, it'll happen. It just won't give you the right product at the end. So what this is doing is, hey, I found some materials here. Do you want me to map the missing materials and packagings? So it found mild steel 0.12, 3/8, et cetera, et cetera. I'm going to go ahead and hit yes. And what that's doing here is, as you can see, some of these hourglasses or whatever they are turning into green checks, stating that the extract of these are happening, right? So what it's doing is getting all the flat patterns, and it's going to create an array of all of the files together. So this takes a little bit of time. While this is all extracting, let me see if I can answer a couple of questions. All right. Boom. Got a question. I have a use for nests of CNC machined parts that are designed to come up from a sheet, typically 1/2 inch aluminum. Can this tool help with this? Certainly. If you need to if you need to cut the parts out of your 1/2 inch aluminum and then machine them afterwards, maybe you've got like some cool embosses and stuff. Yeah, you can totally use this to generate the cut parts and then move forward after that with the rest of it. Cool. So I extracted all of the components. As you can see, I have a bunch of green check boxes. And these source files, right, are just files from that assembly that are flat patterns, right? So I'm going to go ahead and run through this and hit OK. In addition to all of this, let me go ahead and expand this window a little bit. I have an add button, right? And so this is really cool too. Say, for example, I wanted to send that assembly, but I have something else I want to send as well to this particular nest. I can add components to it. And the supported file types here are DXFs, assembly files, and part files. So say I wanted to nest 2 assemblies in one nesting file. I can do that. I can add extra part files if they have flat patterns, and then DXFs as well. So say I have a DXF from AutoCAD, for example, I can actually bring that in, which is kind of cool. So boom. Let me go ahead and hit OK. Once I hit OK, you're going to see my screen's blank, which is really, really interesting. And I found this to be the case every time I've created a nest. So if I actually hit home, all of the parts show up. It's just zoomed in, right, some arbitrary point. So I'm just going to hit the front view, and I'm going to see some information here. As you can see, it gave me all the flat pattern components for the entire assembly. So if I move over, this is every flat component in that assembly, all in one file, right? So it's just an array. And I've seen some customers, right, bring all these DXF flat patterns into AutoCAD, create a master DXF of all of these things after you have to manually sort the thicknesses and the materials, and then send those out to nesting software. Not ideal, right? You want it all to happen real time. So I had a customer who's actually, their workflow, they had assemblies of 150 plus sheet metal components that they needed to nest. It took them anywhere between 3 and 8 hours to convert all of the flat patterns and send them to their nesting software, right, individually off of Inventor or SolidWorks. And then in this case, I took that time down to something like 10, 15 minutes, which is insane in terms of the amount of time savings there. So once I have all my components here, I can go ahead and create the nest. I have some options here. Sources, that's where we went ahead and grabbed all of this information, right? It's where the add is. Nesting properties, I have all of this. I can add multiple quantities of particular files if I wanted to. I can override this. I can send priority. Say, for example, things don't fit entirely. I can edit this priority number. I generally leave everything at 100 because I want everything to get nested. And then some of these other checkboxes are important. I'll go over to them shortly once we actually start with that. But as you can see, it carried over the shape, which is like that part name, the material ID, which it labeled as steel, and then the thicknesses, right? So everything that has the same material ID is going to be the same material and the same thickness. As you can see, ID 4 is steel, and that's 0.375 inches, where this one's 1/2 inch. So just a couple things to note in there. Got a couple of options. This is actually where we create the nests, right? To create the automatic update button. The cool thing is this nest stays associative to the original Inventor model, which is really awesome. And so traditionally in nesting softwares, right, you export a model out of Inventor, you import it into your nesting software, and there is no connection, right? If you need to make an edit to the Inventor model, it doesn't propagate to the nest. And in this case, it does. So that's really important, right? That's part of the power of being in Inventor itself, right? I still have Inventor open, even though I'm in the nesting utility functionality of Inventor. I still have access to, you know, if I wanted to go straight to my assembly, it's just the tab at the bottom, no problem. All right, so let's go ahead and just get started here. Really important before you do get started is the process material library. That's that option over here. This is going to tell you how big those stock pieces are. Essentially, those are called packagings in this case. And so see, I have some packagings that are, you know, all of them are about 50 by 36. But I do know that some of these need to be bigger. I'm just going to change this right now. You can hard override this information. I'm just going to make them 120 by 48. And then I'll do something else as well. Let me do this real quick. And I'll show you how to make other ones as well. In this case, I just want to show that you can override these numbers. But I'm going to go ahead and go to ID 5. I know that this particular packaging I want to change. So I'm going to go ahead and add that. Packaging 8, which is going to be 1 inch mild, smaller. All right, cool. So I'm going to go ahead and change this. I'm going to go ahead and change the length of this to, let's say 60, and I'm going to go ahead and change that to 36. Why? Because I can. So as you can see, I have two things in material 5 now, right? My packaging of just standard packaging 5 and my packaging of 1 inch mild steel are both using, you know, that material ID 5, which happens to be that 1 inch mild steel. And you can override some of this information. You can change colors. The material provider, you can do Inventor. And then when you go through all of this, you can even add materials if you wanted to. In this case, I can, but I'm not really going to. Let me go ahead and just delete this guy. I'll just leave him there for now. All right, cool. So now that I've messed around a little bit with the materials and the packaging, I'm going to go ahead and create the nest. It's as simple as hitting this button or create. And it's going to give me some information, right? It's going to show me all of my source files, all 26 of those files that it brought in. And then it's going to give me information for remnant minimization. I'm just going to leave that alone. Job quantity, right? If you wanted to send 2 of this, stack size, you can send multiple as well. Corner position, right? Do I want my corner to be lower left, lower right, or upper right? And here at the bottom, we have packaging, right? So we've got packagings 2 through 7 because it understands that we need these for these components up here. But it's not actually adding the 1 inch mild smaller that I created just now. But I'm going to go ahead and send that over. As you can see, that came over to this side as well. If I didn't want to use any of the particular materials, say packaging 5, for example, I'm going to go ahead and get rid of that. So I'm actually going to, for anything that's 1/2 inch steel or 1 inch steel, sorry, I'm going to go ahead and use this guy. I'm going to hit OK, and what this is going to do is automatically going to calculate the nest for me. And while it's doing that, I'll go ahead and answer a question. Question, do the parts need to be originally created in sheet metal before they can be placed in the nesting tool, or will it take solid parts and use flat surfaces to create a nest? So right now with the Inventor Nesting Utility, it only takes parts that were created inside of sheet metal itself, that are sheet metal components within Inventor. If you need to do solid parts and carry those over, you can't do that as of right now, but it's something that they're looking at. I've talked to them a little bit before for that. And then another one is, does nesting utility available, or is it available for Inventor 2018? The answer is no. This is only a 2019 thing for now. I can pretty much assume that it's going to be a 19 and moving forward thing. Probably won't go back to 18. So while I answer those questions, this nest got created. And as you can see, we have some very large pieces of packaging that maybe only have one component on them, and the rest is empty. And then some of these where we utilize the entire space. So I'm just going to use this guy as an example right here. You really don't want to send this to your laser and cut what is this, an 8 inch by 4 inch piece, and then leave the rest of this 5 foot by 3 foot piece, and you get a little chunk out of it. Not really ideal in regards to usage of material, but you know what? It's really easy to go ahead and just adjust that. So I'm going to go ahead and double click into that particular nest, and I'm just going at the nest, this particular one, right? I'm not editing them all. As you see, I'm using that new packaging that I named. I'm just going to go ahead and change the quantity, right? So you know what? Let's go ahead and just generate, what's a fun number? Let's just generate 60 of these things. And this is where we're going to get into some of this information as well. And I'm going to change the item separation, and I'm going to go to, oops, 3/4 of an inch. Why not, right? You can change the item separation and the frame width if you really want to for this. And then I'm going to go ahead and OK out. And as you can see, it's automatically calculating the updates for that, and it gave me this component right here. As you can see, it's a little further out because I changed the item separation, and they all didn't fit on one, so it actually put the last one on another sheet. So what I'm going to do here now is let's take a look at this. As you can see, some of these are oriented in one way, some of them are oriented in another way, and that's just to generate the most yield out of this. But say, for example, I wanted all these to be in the same metal grain, for example. I wanted, everything to be in the same kind of grain, so we get the same, surface finish on all of these things. So let me go ahead and do that. And that's where this information comes into play as well, where we have the mirror orientation, the flip and rotates. Having them checked allows the component to flip and rotate to fit, to fit the nest better. In this case, I don't want any of that to happen, right? I want them all to be in the same exact orientation. I'm going to go ahead and start clicking through these and turning these degrees of freedom, or these abilities to rotate and flip off. As you can see, I have the automatically calculate nest checkbox on. So the second I hit this OK button, it's going to go ahead and update this nest, load, and as you can see now, boom, I've got everything in the same exact flipped orientation. They're all, with the hole on the left-hand side of the part there. So something really cool, you can change the quantity, you can change the orientation of these components. One thing that this can't do as of now, right, is if you wanted to manually move one of these guys over, say you wanted this, just for example, to move over maybe down like 1/2 an inch or something. As of right now, you cannot do that, but that's something that development is looking into, adding in the next, releases or so. So just some information for that. Like I mentioned, all of this is kind of related to the model itself. So if I made a change to this actual 3D model, say I made this hole a little bit larger, it'll prompt me to update this nest here. And then once I update it, the hole will either get larger or whatever changes made in the actual model side are going to propagate down to here, which is really cool. So for the sake of time, I'm not going to go ahead and do that. You can try that on your own at home. If you have issues with that, let me know. I'm more than happy to help out with that. You've got also more information up here. I didn't go through here, shaded wireframe, and then change the color stuff. Nothing super, super important. But for now, I'm going to go ahead and stop for a quick minute. I'm going to answer a couple of questions. I do see a lot coming in. I want to make sure I answer all of those before we move on to the next section here. So let's go ahead and take a look. All right. Let's see here. We have assemblies that have wood parts. Will it pick up the metadata and nest them? It depends, right? If those wood parts were created in the sheet metal environment, yes. If they weren't created in the sheet metal environment, no. So that's just a quick caveat there. Right now, it only works with parts that were built in the sheet metal environment in Inventor. You don't have to build sheet metal, or you don't have to build metal parts in the sheet metal environment. You could actually, I think, use materials that are not metals in there. So another question, will this video be available to watch at a later time? Yeah, all of our videos are available to watch on our YouTube channel. That's going to be youtube.com/KETIV Technologies. So if you have a hard time finding that later, let us know. That should be up there in the next day or so. All right. Let's see here. And then the last question before I move on, what if a part started as a standard part and was converted to sheet metal? I'm pretty sure it'll pick that up as long as you can generate a flat pattern from the actual part itself. That information should carry over. But go ahead and give it a try. Let me know. It'd be really interesting to know if the part started out as a standard part, got converted to a sheet metal part. Does it still work? So. All right. Cool. So let's go ahead and continue here. So it's one thing to nest it, right? It's another thing to actually post this out to the machine. As you can see here, I don't have any information to post any of this out to my machine. I just have like iProperties of my nesting file. I've got object visibility, options, nothing too crazy in here. But I want to be able to send this information out to my CNC machine, send it out to my lasers, so on and so forth. How do I do that? Well, you send these nests out one at a time, and you can export these in one of two ways. So I'm going to do that right now. I'm going to use this this particular sheet as an example. This is sheet 10. As you can see, it's got all those items on it. I'm going to go ahead and right-click that, and there's some information here. So there's two ways to export this, right? There's using the standard export functionality. I'm going to go ahead and click that, and it's going to send it out as a DXF file or an MSI file. Generally, it's DXFs. They get sent out to whatever, right? Mastercam. Do you want to send this out to GibbsCam, et cetera, et cetera? You can export them as DXF files. Secondly, and which is like the actual one of my favorite things in regards to doing everything within here, is to create a 3D model out of this. And you may ask, why do I want to create a 3D model out of something that was already a 3D model before? Well, if I create a 3D model out of this, and this will happen while it loads. Just bear with me 1 second. It's going to create a 3D model of that that nest itself, right? That sheet, with a thickness of, I believe, 1 inch, or is it half an inch? That one might be half an inch. We'll see what happens when it loads. As you can see, I have a 3D model now of all those components, and then I have like a, I guess, semi-transparent model box outside that is the stock itself, right, of steel. So really, really cool. And what we can do from now is, right, we're in the Inventor modeling environment. I have a part file. This is my Inventor part file. Let me bring that back. All right, this is an Inventor part file. So you can do anything you can do to part files if you want. You could extrude. You can use some of the freeform modeling if you really want to. Well, the whole purpose of this in generating this particular part is to be able to post it out. And you post it out like you post out any normal part, right? You go from the part 3D modeling environment into the CAM environment. This is that HSM environment in Inventor that also comes with the product design and manufacturing collection. If you don't have the collection, you can actually still get some HSM. You don't get the full HSM. You'll get what's called HSM Express. And that's just 3-axis stuff. So just bear in mind that you have that information, right? So I can go to the CAM environment. And for the sake of time here, I'm not actually going to set this up. It's very simple, though. You just set up one toolpath, right? It is a 2D profile. You select the profiles, and then it automatically cuts. I've already done this for another sheet. I'm going to go ahead and open that right now. Boom. So here's another one. I just generated a 2D profile for this. You can edit some of the information from here, like the curve, so on and so forth. All of that is in here. So if you are familiar with the HSM environment, awesome. It's straightforward, nice and easy to use. And you can even run through a simulation of all of that as well, like you can in the regular HSM environment. Hopefully this comes across okay via the internet. As you can see, I've got my little tool going through all of these components. And this is actually, I think I set this one to laser or plasma. I don't remember. I think it's pretty sure it's laser. But as you can see, it will cut out all those components for you. And then you can post this straight out to your machine, right? You can post this guy, generate the toolpath, all that fun jazz you can do in HSM, right? It's got hundreds of existing post processors in there. If it's not in there, let us know. We have some in-house expertise to be able to help you create some of those posts. For lasers and stuff like that, it is pretty simple, right? Because you're only pretty much working in 2 axes, not like a 5-axis post, which can get a little cumbersome. But yeah, pretty straightforward. So let me go ahead and go back to the nest itself. I showed you, how to generate this nest, how to import the files into Inventor. Import the files from your Inventor assembly into the nesting environment. Generate the nest, change some of the information with the stock sizing. Carry some of that information over. I didn't get any errors this time. I probably should have shown how to look at those. You can look at the reports here, and usually the errors will pop up at the bottom. It tells you the total area, the remnants left, so on and so forth. It's using an algorithm from TrueNest to be able to generate all of this stuff. If the actual packaging is too small, say, for example, to fit this graded component on there, it'll give you an error that says, hey, this part is missing. And then you go ahead and change the size of your actual packaging to accommodate for that. So just a couple of things to keep note. It is the newest thing added to the collection. So if you have any questions, definitely reach out to myself. I have a lot of stick time on this, as well as a couple of other people here on the team. We'll be more than happy to help you with the process through all of this. Also showed you how to get this information out to your exports, whether that's a DXF file to go ahead and send to your preferred CAM software, or the one built straight into Inventor, right? Use the HSM built into the Inventor. The only caveat that I have for that too, before I let everybody jump into Q&A, is that when you generate this part file here off of the nest itself, this is no longer associative to the original model. So if I change the hole size or anything on the original model of this, it will propagate down to the nest. But since we just did a blind export off of the nest, it will not propagate to this part. So keep that in mind. If you have any questions about how that workflow goes, let me know. I'm more than happy to jump on, quick phone call, email chains, whatever, to go ahead and explain that again if need be. So yeah, it's awesome. It's, you know, built in. If you need other higher end capabilities, right, you've got like press brakes and punch presses and stuff like that. There are other tools for those. Autodesk does have some. So if you have any questions about needing higher functionality, stuff like that, let me know. I'll be able to point you in the right direction. But just something, you know, really cool if you have very sheet metal heavy assemblies, to be able to post those out a lot faster than they were before. So with that, I'm going to jump straight into Q&A here, and I'm just going to stay inside of the Inventor environment because I have a feeling I'm probably going to have to show some options. So let's go ahead and take a look. All right, so boom. It's a good thing I answered some of these questions. So let me just go over that again. What formats does the software export, and does the software allow for kerf and minimal in-between material? So yes. So first off, yes, DXFs, and you can export to parts, which is like super awesome because you can stay in that Inventor environment. It doesn't allow for kerf and minimal in-between material. Yes, it does. As you can see, I changed the in-between material let me jump back into Inventor real quick. I changed the in-between material for this particular component. That is as simple as going in here, looking at that nest. I believe this is sheet 10. If you just double click on the nest itself, you can change the item separation. Here, I just changed that to 3/4 of an inch just because I wanted to kind of exaggerate the change, right? So we could actually visualize it, as opposed to some of these cards. And as you can see, they're like much, much closer, right? It's like 1/10 of an inch or something. So we created a sheet metal part and they don't have any flanges. I think you can still get even if it's a sheet metal part with no flanges or bends, I'm pretty sure it still has a flat pattern, it just does nothing. I'd have to double check on that itself. You can probably still send it into here. Let me know if you try that, Robert, and if that works. So let's see here. So Jeremy, I think I answered your question. Can you export the nest as a DXF? Certainly. Boom, export. And then that DXF is right here. Will the nesting utility have future plans to spin, rotate, move cuts to better place parts? I noticed that some items might fit better rotated or spun a bit. Does nesting give an estimate of wasted material for accounting purposes? It does give some information on wasted material. If you look at the actual nesting reports, it gives you this awesome thing that looks like the run command in your computer. It gives you information on the remnants, and you can even do cost, right? Costing per the actual packaging, right? So it'll multiply that information for you. If you need more robust, say, job information, or you want to run all this stuff like 24/7, there is another tool for that. If you like strictly do sheet metal stuff like this, there might be a tool that's better. That does a lot more in regards to the connecting to like your purchasing software, so on and so forth. There's ways to do that. So let me know if that's something you need information on. I'm more than happy to send that information to you. In addition to that, let's see what we got. Yeah, some of the components might fit better if they're spun a little bit or moved around. Certainly, it is using a particular algorithm. They are allowed to spin. it's just how the algorithm, used it. I think this nesting software has one algorithm. One of the other Autodesk softwares has multiple. So just keep that in mind. In the future, you'll be able to manually move some of these around, which will be nice too. If you're smarter than the algorithm, sometimes that happens. Can we use iLogic in the nesting utility? So as you can see, there is the iLogic browser, which is really interesting that it's in here. I don't know what iLogic functionality is built into the nesting side of things. I haven't played around with that yet. I don't think any is, to be honest. I think it just lets you turn the browser on. So, yeah. Alfia, hopefully I answered your question in regards to the reports, right? You just double-click the reports here in the model tree, or the nesting tree, I guess now, and that'll pull out some reports from that nesting information. Can the report migrate to a PLM system? So this is really interesting. If that's something that's required, that you need to send out to a PLM system, you need to connect it to purchasing, so on and so forth. Like I said, there's another tool that has that's a lot more robust, that can do some of that information. So Gage, if you have any interest in that, let me know, and I'll be able to get you the right information for that. All right, where does it pull the costing information from? That's an awesome question, Jeremy. Let me go ahead and go into options again. Or not options, costing materials, or process material library. Sorry, I have the questions popping up on my screen as well as Inventor. It's kind of cumbersome. So the costing information comes from here. I'm in the packaging, and that information comes from here, right? So how much does this particular sheet cost? Let's just say, for the sake of numbers, let's just make this $250. And so that'll carry over there. And then this is the information that it uses when it does the nesting reports. And as you can see here, it needs an update because I changed the cost of the nest. So let me just go ahead and start that. And then if I look at the report, total costs, total remnant costs, information like that, right? So I only used like $2 of material here, as you can see, because, yeah, so that's just information for that. Hopefully that answers your question, Jeremy. If you have any further, let me know. Can you manually rearrange the pattern in the nesting environment? As of right now, no. That's something they're looking into. If you need to do that, there's another software that lets you do that. That Autodesk does create itself as well. It's called TrueNest. If you need information on that, let me know, and I'll be able to do that. In addition, I guess you could edit the DXF files if you export out to DXF, but that's not fun. And last question here from Bob is the product design and manufacturing collection different than the suites? Yes, it is very different than the suites. So the suites were sold as perpetual licenses. Some were sold as subscription licenses as well. The collection is like the new version of the suites. It has a lot more. What they did is they took 7 suites and they made them into like 3 collections. One for the manufacturing space, one for the AEC space, and one for the media and entertainment space. Yes, it is very different. The only way you get HSM, full HSM, the nesting utility, Nastran in CAD, I'll pull up the list again. The way you get all of this stuff in Inventor, or sorry, not Inventor, all in one package is the product design and manufacturing collection. If you have Product Design Suite Ultimate, you'll have Inventor Professional. You won't have any of the other stuff on the top shelf. You'll have some of these AutoCADs and some of the stuff here at the bottom, but not all of it, right? So if you have any questions as to what you have, what your company has, I know a lot of people here are end users. They're not really dealing with the renewals of licenses, so on and so forth. Let me know. And there is a way to transition from the suites into the collections. If you have suites, or maybe you just have a standalone Inventor and AutoCAD, for example, you can transition into it. So just let me know if that question does arise. Last question though, is this new feature available in older versions of Inventor? So no, this feature is only available in Inventor 2019. So it's definitely a good reason to go up to the newest version of Inventor. This is why I installed Inventor 2019, is so I can do cool stuff like this. So yes and no. So no, it's not available in older versions, and yes, you're going to use 2019 to get this information. Awesome. I think that's it for questions. Like I said, if anyone has any further ones, go ahead and email me or give me a call. I'll be more than happy to answer your questions. And And I'm glad to hear that this was useful for a lot of people out there. So next time, maybe we'll take a little bit of a deeper dive into some of these options, but I just wanted to be able to help you all get started using the nesting utility, right? It is something really awesome in 2019. Really excited when I saw it was in there. So hopefully you are too. With that, thanks again for showing up to AVA this week. Next week, we have a special AVA with Kevin Robinson. It's one of our friends from Autodesk. It's going to be one of those special features. So be on the lookout for that information in an email next Wednesday, and be here again next Thursday at 10 a.m. for that AVA. So thanks again for all being part of our community. We'll see you next week, same time, same place. That is how the cookie crumbles.